Before we program anything, the primary subject is to deal with motor parameters first. Moving on, we need to program rated voltage if it's either 220 or 380 or 400 volt. It could be any value, but we need to know and we need to program it. We also need to know the frequency of motor. Typically, it is 50 or 60, but sometimes it could be different value. Next, the rated ampere of motor and the motor kilowatts, that is the capacity or horsepower. So these four values are must to be known and programmed before any other programming. But there are few other parameters which we need to know if we want to use some advanced functions. These advanced functions we will check later in this course. So these parameters are efficiency, rated slip, and motor poles. You can see on the screen the formula for rated slip. But before we discuss that, we need some understanding of the term slip. So what is meant by rated slip? Well, in easy words, the speed difference between flux and rotor. So that means the speed of rotary part of motor, that is known as rotor, will always be less than the field applied. So as an example, field could be applied at 1800 rpm, but the speed will be around 1700 rpm. So in the formula, Fs stands for slip frequency, Fr stands for rated frequency, and P stands for the number of poles, and we know rpm is the rated speed. Next, number of poles. If we generalize and for our ease, if the rpm is near 1800 and the motor rating is 60 Hz, that means the motor is designed on 4 poles. And if it's 1500 rpm and motor is rated 50 Hz, then it's also designed on 4 poles. And lastly, we need to enter motor's no-load current. What no-load current means? It means if the motor is removed from the load and we check that how much current is consumed, that is known as no-load current. But practically, it is difficult to remove the motor from the load. So the rule of thumb is to take the half of the rated current. So if, for example, the motor rating is 2 ampere, we'll put the no-load value as 1 ampere. If the motor rating is 4 ampere, we'll put the no-load current as 2 ampere. I added a motor nameplate and we will get the desired parameters. So we see it's rated 220 or 380 and there are symbols. It's known as star or delta. This is a connection type. So if the motor connections are of delta type, then we will pick the value 220. But in case of star connection, 380 will be the right voltage value. So before we pick the right voltage, I will open the motor connection box and I will check physically whether it is star or delta. So in case if it's star connection, you can see on the screen how the connection look like, and in case of delta, you can see the difference between the primary and secondary coils of the motor. Next, the rated frequency. So in this case, it can be either 50 or 60. Then we see the capacity. So this motor is 0.75 kilowatt, or which is equal to 1 horsepower. Then we see the current. It's written 3.22 or 1.86. But the question is which one to select. So if we go back to the voltage, and in case our connection is delta type and we pick the voltage to be 220, then the right selection will be 3.22 amperes. And in case of star connection, our rated voltage will be 380, then the right selection for current will be 1.86 amps. Now this